Find the support force in the x direction, in newtons. In this problem, water at standard temperature flows through a pipe joint. Water enters the joint through pipe 1 and leaves the joint through pipes 2 and 3. The diameters of pipes 1 and 2 are provided, and the velocity through all 3 pipes equals 5 meters per second. The problem asks to find the support force in the x direction, which is the horizontal force required to resist the hydraulic forces caused by water flowing through the joint. We'll begin by setting the sum of the forces in the x direction equal to 0. Looking at the joint, we'll define forces Fx1, Fx2, and Fx3 to represent the forces on the joint from water flowing through pipes 1, 2, and 3. After expanding the summation, we can solve for the support force in the x direction as Fx1 plus Fx3 cosine theta minus Fx2. After plugging in theta, we can define the hydrodynamic force as the mass flow rate m dot times the velocity through the pipe, v. The mass flow rate equals the density of the fluid, rho, times the flow rate, q. And the velocity equals the flow rate, q, divided by the flow area, a. Now our revised equation for force is rho q squared over a. Substituting this expression in for Fx1, Fx2, and Fx3, our equation for the support force is a function of the density, flow rate, and flow area. We'll first solve for the density of the water, rho, which depends on the temperature, and equals approximately 999 kilograms per meter cubed. Using the diameters provided in the problem statement, areas 1 and 2 equal 7.853 times 10 to the negative third meters squared and 3.142 times 10 to the negative fourth meters squared, respectively. Next, we'll solve for the flow rates through pipes 1 and 2, which equal the velocity through each pipe times the flow area. Since the problem statement provides the velocity as being 5 meters per second, and since we just calculated the flow areas, we compute the flow rates 1 and 2 as 0.03927 meters cubed per second and 1.571 times 10 to the negative third meters cubed per second. The last two variables we need to solve for are the flow rate and flow area through pipe 3. Returning to the figure, we notice the flow rate in pipe 3 must equal the flow rate in pipe 1 minus the flow rate in pipe 2. After plugging in the flow rates for pipes 1 and 2, the flow rate in pipe 3 equals 0.0377 meters cubed per second. The flow area for pipe 3 equals the flow rate divided by the velocity for pipe 3. After plugging in these two values, the flow area of pipe 3 equals 7.54 times 10 to the negative third meters squared. Lastly, we can compute the support force in the pipe joint in the x direction as 321 kilogram meters per second squared, which is the same as 321 newtons. When looking over the possible solutions, the answer is D.